Most gases at room temperature and pressure follow closely with the ideal gas law. PV equals nRT allows us to make quantitative predictions as to how one property depends on the others. But we need to be careful that the units we have are appropriate before we plug those numbers into the equation. So let's think about that. The ideal gas law allows for qualitative and quantitative predictions. To be used quantitatively, we need to pay attention to the units on the measurable quantities. When measuring pressure, the measurement needs to be in atmospheres, abbreviated ATM. Sometimes you'll see pressure measured in torr or in millimeters of mercury. 1 atmosphere pressure equals 760 torr. Volume should be in liters. You will often see a volume measurement given in milliliters. Recall that 1 liter equals 1,000 milliliters. N is in moles. Sometimes we may have information about the grams of a gas, and we can convert between grams and moles using molar mass, as we did earlier in the course. In the ideal gas equation, temperature is in kelvins. The Kelvin scale is about 273 greater than temperature on the degrees Celsius scale. If we have any measurement that are not in atmospheres, liters, moles, or kelvins, we will need to do a conversion before we use the equation. Using all of these units, we will find that the ideal gas constant has the units liter atmospheres per Kelvin mole. The specific value to 3 significant figures is 0.0821. This is a number that will be given in this section of CH 101, but you will probably use it enough that you will just know it. Let's work a problem where we will need to consider the units of the quantities before using the ideal gas law. How many grams of dihydrogen are present in a 400 milliliter sample at 720 torr and 25 degrees C? We're asking for the amount of dihydrogen present. While none of the terms in the ideal gas law are in grams, the amount of the gas is denoted by N, the number of moles. Since we're given a volume, a pressure, and a temperature, we can rearrange the equation to solve for N. Pressure is given in torr rather than in atmosphere. To convert from torr to ATM, we use the conversion factor 1 ATM over 760 torr, yielding a pressure of 0.947 atmospheres. This is the number that is plugged into the equation. Volume needs to be in liters, but is given in the problem in milliliters. The conversion factor is 1 liter divided by 1,000 milliliters, which results in 0.400 liters. This is plugged into the equation for V. R is the ideal gas constant, which is simply plugged in as 0.0821 liter atmospheres per Kelvin mole. Temperature needs to be in kelvins, but is given in degrees Celsius. To convert, we need to add 273 to 25, resulting in a temperature of 298 K. We plug this into the equation as well. Doing the algebra, this comes out to 0.0155 moles of dihydrogen. Finally, to find the grams of dihydrogen, we use the molar mass to convert from moles to grams. The final result is 0.0312 grams of dihydrogen. It's important to remember to check the units of what is given and what we're trying to find in an ideal gas problem, and convert them if necessary to the proper units before plugging them into the ideal gas law.